Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 8.4 entitled Division Properties of Exponents. And today we're going to take a look at the quotient properties, the quotient of powers property, and then the power of a quotient property. And these are just two division properties that are going to help us simplify exponential expressions so that we only have positive exponents when we're done. Now the quotient of powers property, before I get into the definition here, I'm going to take a look at this expression here where we have 4 to the 5th and 4 to the 3rd. Now remember that 4 to the 5th is really 4 times itself 5 times. And then 4 to the 3rd is 4 times itself 3 times. Now when I have a fraction where terms are the same from the top to the bottom, I can cancel them out. So I can cancel out 3 of those 4's. So that leaves me with 4 times 4, which is 4 squared, which is 16. But the rule that we need to focus on here is going from 4 to the 5th over 4 to the 3rd to 4 to the 2nd. And the shortcut for doing that is to take 5 minus 3. So that's what our quotient of powers property says. It says that when you are dividing powers that have the same base, again, they have to have the same base. So the 4's here are the same. So if this was a 4 and this was a 2, we couldn't do it. So when you have the same bases, you can subtract the exponents. Now we've talked about this a little bit in section 8.2, and I referred to this type of a problem as being top heavy because there's a bigger exponent in the numerator than there is in the denominator. So your answer, your leftovers after you subtract, will be in the numerator as well. If it was reversed, then that would be bottom heavy, where you have a bigger a bigger exponent in the denominator than you do in the numerator. And your book is going to rewrite these expressions in a slightly different way. They're going to have a to the m over a to the nth equals a to the m minus n. That's the expression your book is going to use for this rule. So if you see that, that's what that means. And then we also have the power of a quotient property. And this is basically saying that we're going to distribute our exponent. And even when we have a fraction here inside the parentheses, we're going to take that exponent and distribute it to every part of the numerator and the denominator. So we'll have 2 to the 4th over 3 to the 4th. Now you could write this all out, 2 times 2 times 2 times 2 times 2, or 3 times 3 times 3 times 3. Now you don't necessarily need to do that. I know now that you can type this into your calculator. So 2 to the 4th is 16, and 3 to the 4th is 81. So that's how you get your simplified answer. Now, again, the key is knowing that you have to distribute that exponent to every single term. And again, if this was a fraction that we could reduce, we would want to do that. And your book is going to write this as a over b to the m equals a to the m over b to the m. So again, if you see that when you're looking in the book, this is what they're referring to. It's this rule here where you distribute that exponent. So we're going to take a look at some examples where we use these properties, and then we're going to look at more and more complicated expressions as we go through the notes. Now for part A here, again, for all of these types of problems, we're trying to fill in the little blank there where the little question mark is. So we're trying to figure out what number or what term goes in that spot. So I have 4 to the 7th over 4 to the 5th equals 4 to the something. So here again, we're dividing our bases, and the bases are the same. So that means I can just subtract. 7 minus 5 will get me that something that I need. And that something is going to be the 2. So this would be 4 squared. Now part B is a little more advanced. I have x to the 8th over x to the something. And again, that something is what I need to figure out. Since my bases are the same, I know I subtracted. So they took 8 minus something, and they got 13. Now, usually when you subtract, you get a smaller number. But here they subtracted and they got a bigger number. That means that they subtracted a negative. So we need some negative number that's going to go in here. Because when you subtract a negative, that's really like adding a positive. So you want to think, okay, 8 plus what is 13? And that something is a 5. But remember, it's subtraction, so it's really 8 minus a negative 5 equals that 13. So your something is going to be a negative 5. So you might see that as you're working through these problems, you might see more negative exponents appearing. And we've dealt with negative exponents in section 8.2. So remember, you might have an expression like 2 to the 3rd over 2 to the 5th. So when you subtract, you get 2 to the negative 2. And then you'd have to move that down to the denominator. Okay? So there's a couple different ways that you can think through that thought process, but that's very similar to what we did here in part B. You're still subtracting, but the bottom is bigger, so your exponent, your leftovers, are going to stay in the denominator. Okay? For part C, this is where we're going to be distributing our exponent. So I have negative 4 over 6 that I'm squaring. So I'm going to square the top and square the bottom. And then when I square my numerator, remember that negative 4 gets squared. So I'm going to take negative 4 times negative 4, and I'll get 16. And then 6 times 6 is 36. So now I can see that they wanted me to figure out that the numerator is what's going to actually be my answer there to fill in the blank. So that 16 is going to be that little question mark that they wanted me to fill in. So some of the problems with these little question marks are going to be more straightforward, like we've seen in the past. Some of them, like C and D, you might have to do a little more work for. Okay, so for part D, again, we're going to distribute our exponent to everything that's inside that little fractional term here, inside the parentheses. But we're distributing a negative exponent. That's okay. It still works the same way. This rule still applies. Now, they want me to figure out what ends up going in my denominator, but I have to completely simplify this expression first, because I don't want to have any negative exponents in my expressions. I want them all to have positive exponents. And now that I've distributed in my numerator, you can see that I have a power to a power. So there I have to multiply. That was one of the rules that we saw in the very first section, 8.1. And now I have two terms that have negative exponents. So this y to the 4th, I have to move him up to the numerator, so he becomes y to the positive 4th. And this x to the negative 8, I have to move him down to the denominator, so he becomes an x to the positive 8. So remember that when you're dealing with negative exponents, if they're negative in the numerator, you move them to the denominator. If they're negative in the denominator, you move them to the numerator. And now I can see that now I have a y to the 4th in my numerator, and this little question mark that they wanted me to find, that's my x to the 8th here in the denominator. So we had to do a little more work for C and D to figure out what needed to fill in that spot for the question mark. But just remember, as you work through those problems, you have to have all positive exponents at the end. Okay, for example 2, we're still going to be using those two new properties of the quotient properties that we've talked about. We're just not going to have any more little question marks. We're going to have to work through these all on our own. And for part A, I have 1 over 3 to the 4th times 3 to the 7th. And I'm going to put this 3 to the 7th over a 1. So now I have a fraction times a fraction. You know when you multiply fractions, you multiply straight across. So 1 times 3 to the 7th, that's just 3 to the 7th. And 1 times 3 to the 4th, that's just going to be 3 to the 4th. So now I have a problem that's very similar to part A in example 1. So since my bases are the same, I can subtract my exponents. So 7 minus 4 will be 3. So I'll end up with 3 to the 3rd. And I can simplify that further. I can actually calculate that, which will be 27. Now, if it was a number like 3 to the 20th power, I wouldn't expect you to simplify that. That's a huge number. Your calculator will put it in scientific notation, so it's actually more awkward to write it out that way instead of just leaving it with a big exponent. But 3 to the 3rd, that's simple enough that we can evaluate that. So go ahead and evaluate them when they're relatively decent numbers. Okay. For part B now, we're going to have two steps that we have to do. I have to simplify my numerator here, where I have like bases that are multiplying. So I'm going to add my exponents. So I'll have 4 to the 5th over 4 to the 7th. Now here, my numerator is smaller than my denominator. So there's a couple ways that you can think of this. Okay, this is like what I was referring to up above here in this little green bubbly cloud note that I wrote. Okay, one way to think of this is to say, okay, my bases are the same, so I'm going to subtract. So 5 minus 7, that's negative 2. But now I have a negative exponent in my numerator. I can't have negative exponents. So I have to move him to the denominator where he'll be positive. And then I don't have anything in my numerator anymore, so I'm just going to put a 1 there. So then I can simplify that as 1 over 16. The other way to think about this is to say, okay, I have 4 to the 5th over 4 to the 7th. And I know that this is really like 4 times 4 times 4 times 4 times 4. I've got 5 of them. And here I'd have 7, 2, 3, 4, 5, 6, 7. And I know I can cancel, so I'd cancel off 5 of them. So I have 2 left, and those 2 that are left are in the denominator. So this fraction is bottom heavy. So either way you want to think of it, you end up with 1 over 16. Okay, so if you're comfortable with the negative exponents, you can use this example here in blue or this work in blue as your guide. If you're not real comfortable with the negative exponents, just think, okay, I'm still subtracting. 7 minus 5 is 2, but I had more in the bottom, so my terms that don't cancel are going to be left in the bottom of my expression. So I'm going to get a fraction that's 1 over 16. Okay, so for part C now and part D, I'm going to distribute. I'm going to distribute my exponents, very similar to what we did in part C and D in example 1. So I'm going to cube the top and cube the bottom here. And remember, I have negative x that's getting cubed and a 5 that's getting cubed. So when I write that negative x, I have to write it in parentheses, okay? Because that means I have negative x times negative x times negative x. So negative times negative is a positive, times a negative is a negative. So I get a negative. I have 1, 2, 3 x's, so that's negative x to the 3rd. Anything that's an odd power is going to end up being negative when you have a negative here inside the parentheses. Anything that's an even power will be positive when you have the negative inside the parentheses. So that's a little tip. And then 5 to the third, I can do that. That's 5 times 5 times 5. So that's going to be 125. So there's my simplified expression. Okay. And part D, I'm still going to distribute, except now I'm distributing a negative exponent. It's okay. Distribute it first. So I have 3 to the negative 2 and 4 to the negative 2. Now, a common mistake is that students often confuse this negative in the exponent with this negative that's with the base, or that's out front of the whole term. Don't confuse those. They're different negatives. They mean different things. These negatives mean I have to move my terms. These negative exponents tell me I have to move them so that they'll be positive. So this 4 to the negative 2, since he's in the denominator, I have to move him up to the numerator and make him a positive exponent. And this 3 to the negative 2, since he's negative in the numerator, I have to move him down to the denominator, so he'll be positive. Now I can simplify it. So 4 squared is going to be 16, and 3 squared is 9. So both of these problems, C and D, these are quiz or test level problems. You should be able to do those two examples with no problems on a quiz or a test. And if you're confused right now, then you either need to come in and get help before school, or you need to do your homework, or go to the tutoring after schools on Tuesdays and Thursdays, or before school on Thursday mornings, or after school on Sundays, okay? We're getting to more complicated problems now. A lot of different rules and a lot of different properties, so you're going to have to practice and really get these rules down. So, before we look at example 3, we have example 3 and example 4 left over. Example 3 gets as complicated as it's going to get. This is the toughest stuff we're going to see with our exponents because it's got everything in them. So definitely write these steps down because these are the steps you can follow and go through to make sure that you're successful every single time when you see really big, complicated exponential expressions. So if we have to distribute any exponents, we're going to do that. We'll do it to all parts of the problem or all parts of the fraction. Then after you do that, if you have a power to a power, multiply them. After you do that, you still might have some negative exponents left over, so move them. If they're negative in the numerator, move them to the denominator. If they're negative in the denominator, move them to the numerator. Then you can do the stuff that we did in section 8.1, where you multiply all the way across the numerator and denominator so you get one term. And then if you have a fraction, you should have one term in your numerator, one term in your denominator. If the bases are the same, then you can subtract them. Okay, so these are the steps that we're going to follow as we go through these next two examples. And those look pretty tough and intimidating, but they're not. If we follow those rules, we'll be fine. Now, my first rule was to distribute if I had anything to distribute, and in part A, I don't have anything to distribute in either of those expressions. Next step was to do a power to a power. Again, I don't have any of that anywhere. I don't have any parentheses. I don't have, 3 to the x to the 4th power or anything like that. So those first two steps I get to skip for this example. But I do have negative exponents. So that's what I'm going to focus on moving now. Okay? And I'm just going to work on this first term here. My x squared just stays x squared. He's positive. He can stay there. This x, he's good. He's positive. He can just stay there. If you want to write in the little 1 so you know it's x to the first, you can. But this y to the 4th in the denominator, he's negative. So I'm going to have to move him up to the numerator. So he will now be here, y to the positive 4. I'm going to do that for my next term as well. Now, here's where you have a little bit of control. You can move this in a couple different ways. You can go term by term and relocate them, Or you can just look at the positive ones and rewrite them and then move the negative ones. Sometimes I think that's easier. Okay, so this 2, he's positive, he's going to stay. This x to the third, he's negative, so I'll move him in a moment. But this y to the fourth, he's positive, so he's going to stay. So I have to come back and I have to move this x to the negative 3. He's negative, so I have to move him down in a moment. This 3 is positive, so he'll stay. This x has a positive exponent, so he'll stay. But this y to the negative 1, he's negative. So I'm going to have to move him up to the numerator. So let me do that now, y to the first. And then let me go back and get this x to the negative 3. He was negative here in the numerator, so I'm going to move him down to the denominator so he'll be positive. So the only terms that I've moved are just the negative ones, the ones that have negative exponents. And now I'm on to my last 2 steps. Now I'm going to multiply across the numerator and across the denominator. So I have one big numerator, one big denominator. Now when I do that, remember, I'm multiplying. So there's multiplication going on between all of these terms. Now I'm going to start with my numbers, my coefficient. So I don't have any other coefficients, so I can just leave the 2. I have an x squared, and he's my only x squared, so I'll leave him. But then the y's, I have 4 of them, and then another 4, and then 1. So when you're multiplying your bases that are the same, remember you're adding your exponents. So I really have 4 plus 4 plus 1. I really have y to the 9th. But now I have one numerator with all my numbers, all my x's, all my y's. So same thing in the denominator. I'm going to leave that 3. He's my only number, my only coefficient. My x's, let's see, I have 1 here, and I have 1 there, and 3 there. So since the x's all have the same bases, I'm going to add 1 plus 1 plus 3. So I have x to the 5th. Now, the only other thing I need to do is divide, and I can only divide or subtract the exponents when the bases are the same. And I have that happening right here for my x's. So I have x to the 5th and x to the 2nd. So this is going to be bottom heavy. So when I subtract 5 minus 2, I get 3. So 5 minus 2 is 3. But because I had more x's in the denominator, that x to the 3rd is going to stay in the denominator. So it's kind of like canceling off 2 from the top and 2 from the bottom. So I'll have the 2, and I'll have my y to the 9th. But that x squared is going to cancel with 2 of them in the bottom as well. So now I have 3x to the 3rd in the denominator. And that's all that I can do for that problem. I can't simplify the 2 and the 3 because that's as reduced as it can get. So I'm done. Now that problem took a little bit of time because I was going slowly, explaining every step. Okay. The more you do these though, the faster it goes. Okay, now part B is going to be very similar, except I do have some distribution here. Okay, I don't have any distribution in my first part, but I do in the second. So I have to take this 2 and I have to basically square every single term. So if you want to write in the little arrows like that so that everything gets squared, you can. So I'm going to leave my first term, x squared, y squared, and then x to the first if you want to write that in, and y to the 3rd. Okay, then I'm going to have 4 squared. Now you can either write 4 squared or you can write 16, doesn't matter. Then I'm going to have x to the 3rd squared, and then I'll have x squared, and then y to the 5th squared. So now notice that after I've distributed that 2 to every single term, now I have a couple power to a power issues. So I'm going to have to multiply these. So again, my first term, I'm not doing anything with it yet, so I'll just rewrite it. x to the first, y to the third. Now this 4 squared, I'm going to write it as 16. X to the third squared, that's a power to a power, so I'm going to multiply, so I get 6. Common mistake is for students to add those. Okay, but remember, power to a power, you multiply. I'm going to leave my x squared, and then I have y to the 5th squared, so that'll be y to the 10th. Now, the nice thing about this problem is that I don't have any negative exponents, so I don't have to move anything around. But now I do have to multiply all the way across the numerator and the denominator, so I get one big numerator and one big denominator. So when I do that, I'll have 6 times 16. That's going to be 96. I have 2 x's here and 6 of them there, so I have 8 of them. And then I have y squared. In the denominator, I don't have any numbers, any coefficients, so I can just go to my x's, which I have 3 of them. And my y's, I'm going to have 13 of them all together. So I'm almost done. I have one last step. Now I can't reduce the 96 at all. That's just a number. There's no other number to reduce it with in the denominator. There's a 1 there. Okay? But my x's, I can subtract. Okay, I've got 8 on the top and 3 on the bottom. So 8 minus 3 is 5. There were more on the top, so that x to the 5th is going to stay in the numerator. In my denominator, I'm going to keep my y's. I have 13 minus 2 is 11. And there are more in the denominator, so that y to the 11th is going to stay in my denominator. And again, there's multiple ways that you can think through this part here. You could think 2 minus 13 is y to the negative 11th, but it would be negative 11 in the numerator, so you have to move it down to the denominator. Okay, so you can still work through that thinking of the negative exponents. Okay, we have one last concept, and this is pretty easy. This is just a cool thing that you can do with exponents and scientific notation. And here we're going to multiply and divide in scientific notation. And we're going to use those properties of exponents that we've been talking about. So when you have a problem like this, you're not going to rewrite the expression in a big long number. I'm not going to write 1.4 times 10 to the 4th and write it as 14000 and then write this as 7600 and then multiply them together and then rewrite my answer back in scientific notation. That takes too long, okay? So the shortcut is I'm going to multiply my numbers. 1.4 times 7.6. Use your calculator and you get 10.64. Okay, so I'm multiplying. That's the operation that's going on between those parentheses. And then I still have to write it as 10 to some power. So I'm going to rewrite it as 10 to the, well, what am I doing here with those 10s? I'm multiplying them. So when the bases are the same, you add the exponents. So 4 plus 3 is 7. Now, before you completely walk away from a problem like this, though, you have to make sure that your answer is in scientific notation at the end. Now, scientific notation, remember, this number has to be between 1 and 10. So I have to scooch this decimal back a place. If I scooch the decimal back here, then I'll have a number that's between 1 and 10. So I'm going to have 1.064 times 10 to the, now you got to think through this, okay? Think like here, the decimal's waiting in line, and this positive 7 means that he gets to move 7 spaces to the right. So he's got 7 spaces to move before he's at the front of the line, okay? So where he's waiting, he moved back 1 space. So now if he wants to get to the front of the line, he's got to move 8 spaces. He's got to move this space back again and the other 7 that he had to go. So there's my answer in scientific notation. And I didn't have to rewrite any big numbers. Now this problem has relatively small exponents. It's a 4 and a 3. So you could rewrite these numbers, multiply them out, and then rewrite your answer in scientific notation. But if these exponents are huge, like 23 or 17, you don't want to write out numbers that are that big and try to multiply them. So this is meant to save time. And it works for division too. Okay, I'm going to take my numbers, the 1.2 and the 4.8, and I'm going to divide them. Use your calculator and you get 0.25. And then the exponents, just like the properties we've been using, I'm going to take the -1 and subtract a -4. So -1 minus a -4 is like plus a +4. So that'll get me 10 to the third. But again, I have to make sure that this is in scientific notation. This number has to be between 1 and 10, and it's not. So I have to move it one space to the right. So then I get 2.5 times 10 to some power, and I have to adjust that power as well. So right here, the decimal was standing in line, and this is positive, so he needed to go 3 spaces to the right to get to the front of the line. I moved him forward 1. So now he only has 2 more spaces to go to get to the front of the line. Okay, part C, this is our very last one. And this is where we're going to use that distribution property for exponents. So you could think of this, if you wanted to, as 4 times 10 to the -2 times 4 times 10 to the -2 times 4 times 10 to the -2. You could write it out 3 times, or just distribute that 3 to the number and to the 10. So you'll have 4 to the third times 10 to the -2 to the third. Now 4 to the third, that's going to be 64. Do that on your calculator if you don't know that. And then here you have a power to a power. So you're going to multiply. So you get 10 to the -6. Now again, take a look at your answer. Make sure it's in scientific notation. And this first number isn't between 1 and 10. Remember, there's a little invisible decimal behind the 64 there. Okay? So again, I have to move that decimal back 1 spot. So this is really going to be 6.4 times 10 to some power, and I have to adjust that power as well. Now, when the decimal was here behind the 4, it had to move 6 spaces to the left. That's what that negative exponent means. So he was standing in a line that was moving over to the left, and he had 6 spaces to go. Well, I moved him forward 1 space. So now he only has 5 more spaces to go. So what we've talked about today then is basically these 2 rules of our exponents, okay, where you have a subtraction property going on, or you have a distribution property going on. But we've seen these rules in combination with the other ones that we've done in the past, and then we've seen them in big problems where all the steps are happening together. And then we've also seen them with scientific notation. So there's a lot of concepts that we talked about in this section, a lot of little concepts. So some of the homework is on page 465 and some of it is on page 473. These problems here, these are the scientific notation problems. Okay? Everything else here, this is all the properties with the dividing of the exponents. And definitely practice these problems, especially those really big ones like we saw in example 3. Those are going to be the ones that are going to be the trickiest just because there's so many steps. But use the steps, go through them one at a time, make sure you have them out while you're doing your homework, and it should make the process go easier for you. But if you have any questions, come on in and see us before school.